From 438 miles above Earth's surface, the newest Landsat satellite will collect data so detailed it can detect both natural and human-caused changes to the landscape. But what really makes Landsat unique is the half-century of data, an unbroken chain of observations over 5 decades. Let's take a look at how we got here. 1966, the U.S. Geological Survey proposes a satellite to study Earth's land masses. But what would that look like? Over the next few years, USGS and NASA researched their options. 1970, NASA gets the green light to build an Earth Resources Technology satellite, an experiment to study and monitor our planet's land surface from space. Launched in '72, this was the first digital data of Earth, repeated at regular intervals with geometric fidelity to allow comparison between observations. This changed how we drew maps, tabulated agricultural production, and assessed damage after disasters. In 1975, NASA launched a second satellite, similar to the first. Now they were collecting twice as much data. With Landsat 3 replacing the aging original in '78, focus shifted to the advanced technology planned for the '80s. The Thematic Mapper instrument, launched on Landsat 4 in 1982 and on its twin Landsat 5 in '84, was a major step forward. Collecting 7 different wavelengths, at better ground resolution, and with higher precision, this was the beating heart of the satellite and became the workhorse for a generation of scientists. For the first time, Landsat data had 3 visible bands, red, green, and blue, allowing natural color composite images. With the addition of shortwave infrared wavelengths, the data could better highlight flooded areas, mineral deposits, and burn scars from wildfires. The thermal bands were also upgraded, allowing individual farm fields to be tracked. The 6th Landsat was intended to be another big step forward, but it never reached orbit after launch in 1993. Plans immediately began for Landsat 7, which would carry an even more improved sensor. At the time, the Enhanced Thematic Mapper Plus was the most stable Earth observation instrument ever sent into orbit, and the calibration could be updated while in space. For the first time, we had an instrument robust enough to collect lots of data, and we had a plan to thoroughly record the entire globe. Landsat 7 was put to work mapping coral reefs, and even produced the first high-resolution natural color map of remote Antarctica. Improvements to the thermal bands on Landsat 7 allowed states and counties to gauge how much water was used by crops. This helps them manage water resources efficiently. An important milestone occurred in 2008, when the USGS made the data available to download for free. Users were able to get the data they needed, and not just what they could afford. It really unlocked a ton of innovation and created about $2 billion a year in economic benefits. The modern era of Landsat observations began with the launch of Landsat 8 in 2013. Having a push-broom-style sensor on Landsat 8 was a big improvement over the older scanning sensor. The Landsat 8 ground system that USGS runs is capable of receiving a lot more data than before. We're downloading over 725 scenes each day. That just wasn't remotely possible until Landsat 8. The 2 European Sentinel-2 satellites were designed to mesh with Landsat so that users can treat data from all the satellites as if it came from one single source. Now we get observations every 2 or 3 days instead of every 2 weeks. 2021 is the launch of Landsat 9, the next step forward. It will collect the best data ever recorded by a Landsat satellite, while still integrating seamlessly with the extensive archive. Since the early 1970s, Landsat satellites have allowed us to better manage our resources. Landsat data has enabled countless innovations and will let us track the effects of climate change into the